A very warm welcome to one and all. This is Team 47. Our topic is CPU Scheduling Algorithms website. Myself, Debayan Rakshit, and I will be taking you through our project. So let's start. Here, as you can see, this is our website page for scheduling algorithms. We've implemented all the 9 algorithms, and the algorithms with IO burst time have been embedded directly inside all these algorithms. So there's no need to like get an extra button or for other access ways. First of all, I would like to show you an introduction of what are CPU scheduling algorithms. If you read it out thoroughly, then you'll get definitely you'll get an explanation of what exactly are CPU scheduling algorithms. So now first off, let's get started with our very first algorithm, that is first come first serve algorithm. So now what is first come first serve algorithm? Well, first come FCFS scheduling, that is its abbreviation. FCFS scheduling works on a simple logic that is that it assembles all the processes according on the basis of their arrival times, right? So I'll just instruct you through that how our website functions. So you have to do nothing. You just have to feed in some processes, respective processes as per your need, and you have to click in this add process button. As soon as you press over this add process button, it will display the process into this queue, right? And if you are just simply pressing over this, then it will show you these red exclamation marks because there is an empty slot and there is nothing to add in it. So right now I'll just feed in some dummy values for your understanding, right? uh, and after you're done adding all the processes in this schedule, then you just have to press this calculate button. Then you'll get our completion time, waiting time, and turnaround time, right? Now obviously just looking at the numbers, you'll never be convinced, or rather be and you'll ever be able to understand that what exactly is happening. So you can just have a look at our visualization page. This is the page, this is this thing, the queue right here, what you can see is termed as Gantt chart, but basically this is the queue inside the CPU and how the processes are being scheduled right here. If I'll add processes accordingly, you can add a process up till 10, and these are not preset values. I repeat, these are not preset values. You can definitely make changes in them as per your need, right? As per your need, you can definitely make changes in them and they'll get sorted accordingly. And we also have one more attribute integrated in this, and that is the context switch time. Now what is context switch time? Context switch time is that the CPU would halt for a while switching into the next process. Like from P1 to P2, it will halt for 0.2 seconds as I've entered added 0.2. You can add as per your need as required, and as you add up, the time scale below it would keep on increasing as per need. And yes, even if you want more detailed explanation, then you could just put your cursor over it so that you can have the process name, its start time, duration, and end time, right? So now as we are convinced with this, let's get to the IO burst time approach. So we'll feed in some dummy values in it. So right, as you can see, it functions similarly to all the precessive algorithms. There's nothing different in the functioning. It is just the fact that we have integrated the initial CPU burst time and the final CPU burst time. After we are done adding the processes, you just have to press over the calculate button. So you'll get the completion time, waiting time, and the turnaround time accordingly, right? You could just verify all these values after with a pen and paper, but this is for your implementation part, for your convenience, like for faster calculations, right? So now let's head for our next algorithm, and that is shortest job first. Shortest job first is an algorithm wherein the assembling is done on the basis of the burst time. I mean, herein, in the shortest job first scheduling algorithm, the process with the shortest execution time would be selected for execution, right? So right here, I guess you'll get a better understanding with by putting in, adding up some value, by implementing it. So I'll just feed in some dummy values as per your convenience, right? For for better understanding. So after you're done, you just have to press at this calculate button, and you'll get the entire schedule in a sorted way, right? So after we are done, obviously again, since it is a new algorithm, definitely by just looking at the numbers you might be more and more getting more fussy. It looks quite fussy and quite confusing. So for basic, for just framing a basic outlay, or and for better understanding, here is a visualization page, and you can just add in processes. It functions similar. All the 9 algorithms have the same functioning. It's just the fact that their way, or means their interface is completely similar. Just it stands different because the type of algorithms are different. And herein as well, all the algorithms have, you can change the values. These are simply just dummy values, right? So as we are done with this visualization, let's get to the SGF with IO burst time. It functions in a similar way, but IO burst time is nothing but it will wait for the user for to enter some values input, right? So this is the IO burst time. You could have a look at it, and we're done. So next up we have shortest remaining time first, which is abbreviated as SRTF. So what is SRTF? SRTF is basically nothing but a preemptive approach of SGF, and if you want to know more about preemptive approach, you could refer to our theory page. So that here we have listed out what exactly is preemptive scheduling and what exactly is non-preemptive scheduling, right? So now let's get back to our algorithm. So herein I think that after feeding some dummy values, you'll get a better understanding, right? So I'll just feed in some values as per your convenience. Oh, sorry. I guess I just simply I forgot to add some more processes, right? So here for now we just added 2 processes in the queue, so we got 2 processes sorted out. Uh, if you want, we can again add up, right? Just hold on. I will just add some more processes for better understanding, you know. So 7. Right now I'm just adding any dummy values for just to show you how it functions. Later on you can just implement it as per your need. You can just feed in the values respectively, and you'll get a better understanding. So here you can see you'll get the completion time, waiting time, and turnaround time. And again, for a better explanation or in a layman approach, here is our visualization page. So herein you can add values accordingly, and you will get an exact explanation as per your need, right? So now I'll take you to our IO burst time approach. So I'll feed in some values. So here I'll press the IO burst time button. So this is how it will function, right? So next up we'll get to next round. Next algorithm is round robin, abbreviated as RR. Now round robin stands out completely different from rest of all 8 algorithms because its way of functioning is quite peculiar and quite unique, because it doesn't go on any kind of approach. It works on a different approach, and that is time quantum, right? Time quantum. Now what is time quantum? Time quantum is simply like the CPU will only consume processes as per instructed by the time quantum. Like it will consume only that much burst time of that particular process as much as it has been instructed by the time quantum. So I will just feed in some values. So how does this round robin function? It will function similarly like all the preceding algorithms, but only the different thing is like after you are done adding all the processes right in here, right, then you have to add a time quantum. right? You could just work it out afterwards as per your need, or you can just implement for your convenience. And here also we have that CPU chart, and here you can see these are in fragmented parts, since uh, the CPU is only being allowed to consume only 2 units of burst time from each and every process. Right now, if I increase the time quantum, you'll notice that fragmentation will decrease gradually, and at a point where the time quantum is equal to the largest burst time, the fragmentation would be null, completely null. There would be no fragmentation, and as you decrease the time quantum, there will be more fragmentations will keep on increasing, right? So as we are done here, I'll take you to our IO burst time. IO burst time is similar to all other algorithms. You will even in round robin as well. You just have to feed in some values, all your all whatever values you wish to feed right here, and you have to add some certain amount of time quantum and calculate. So here is it, right? Next up, we have longest job first algorithm. Now, what is longest job first? Longest job first, you can consider it as a complete opposite for shortest job first, because longest job first functions with over, like it assembles, or rather like refines and assembles the processes on the basis of their burst, on the basis of the longest execution time. I mean, the process with the highest execution, with the highest burst time, would be executed first in the queue. So I'll just, for as usual, I'll just put in some values. Even right here, all the interface is same, so I don't think so you might find any trouble entering processes in it. When you are done, you have to press this calculate button. So here we are with all our processes sorted out. Here, as you can see, according to the IO burst time, process number 9 had the highest burst time, so it was arranged at the topmost priority. But obviously, first priority is always the arrival time, then comes next up is always the burst time, right? So now let's take our visualization approach. So this is the page for visualization. Even herein you can add some values as per your need, and like now you'll see, now if I make it 60, then P4 would be pushed directly to the first, since it has the highest burst time, right? And since all the processes are having the same arrival time, so it will directly get pushed into the first. So I'll take you to our IO burst time page. So here, as you can see, this is the IO burst time values. Now we have LRTF. LRTF is similar, like it is a complete opposite of SRTF, and it is also known as LJFs. It is also known as LJF with a preemptive approach. Right? So as again, I'll add in some values. Right? Add some values. And here you'll get all your values sorted out, right? Again, for your better understanding, or better explanation, we have our visualization page. You can add in processes and reduce as well as per your need, right? This is our IO burst time, so I'll just add some values. So this would be all our values. Next up, we have priority 1 and priority 2. So there's nothing like priority 1 and priority 2. Yours is just for more convenience. We've termed it as priority 1 and priority 2. Priority 1 is non-preemptive, as you can see behind in the screen, and priority 2 is the preemptive approach of the priority scheduling algorithms. So first of all, we will start with priority scheduling and preemptive approach. Now, priority-based scheduling is nothing but the the processes would be arranged according to the priority, right? So now I'll just feed in some values. And this is our visualization page where you can also change the priority as per your need and as you wish for, right? Now since I have entered here 1 means the lowest number will be considered the highest priority, so since P5 is the highest priority, it would be pushed at top at the first process, and since the arrival time for each and every process is 0, right? So yes, we have our IO burst time. I'll add in some processes. So here is it, as you can see. You can verify later on. Now we have priority with preemptive approach. So it is nothing but priority with preemptive way, as you have done in your preceding algorithms. It functions in a similar way, but just with a preemptive approach, right? So yes. So this is your sorted queue, and we also have made a visualization button for this. So it is completely same, it will just function as per its need. So you can just check it out afterwards. And yes, one more thing, if in case you have any doubts and reservations, you can definitely refer to our readme file. It will give a better detailed explanation about in a theoretical approach about for each and every algorithm, and we have also tried out our best to complete all your doubts regarding any algorithm, or rather how it functions. So I'll just take you through its preemptive approach for priority algorithm. And I just have to press the calculate button, right? So we are done with 8 of most important algorithms. Next we have highest response ratio next. Now this is a this is quite similar to the rest of the 7 algorithms except a round robin, but this is a kind of algorithm which has only a non-preemptive approach. So this is quite its way of functioning is a little bit, it stands out a little bit different. So I'll just add in values for your better explanation, and you can just have a look over it. Okay? So after calculating, you'll get all the values. So this was all from our end. We are done with all 9 algorithms and IO burst times, values as well. And yes, you can have an access to our project as well. You can just read out thoroughly our readme file, where you will be instructed accordingly that how to access our project and how to use it for your further working and implementation purposes as well. So that's all, and on behalf of team 47, this is Deban Rakshit. We thank you for viewing our algorithms. And this is team for once again. This is team 47 signing off.